Good morning, ma'am. Shobna, ma'am, audible?
Audible, sir.
coating also like that. So these variations are classified with the crystal system as well as the material system. The nanomaterials, that is nanoparticles, as well as nanocrystals like that. Next slide, please. Yeah, crystalline materials. What we are doing in lab, it is said to be macro scale, and when you are slightly crushed or powder exactly what we are taking, it's said to be in micro scale. And further, by ball milling method, it is converted into nanoscale or nanocrystalline material like that. And particle or powder material, that is nano materials directly we are extracting from the plants, green synthesis method or some other methods, that hydrothermal method and co-precipitation method like that. So that is directly nano powders or nano materials extract directly we are getting. They are direct nanometer scale like that. Here we are converting the macro into nanoscale in the crystalline material. Next slide, please. Yeah, non-linear optics. So it's mainly connected to crystals. This non-linear optical system or non-linear optics is mainly connected or related to the crystal system. The crystals are differentiated as linear optical system, that is non-NLO. They are called as centrosymmetric and non-centrosymmetric like that. So based on that, we are having enhanced optical properties and enhanced some other filter applications based on this NLO. So the material which is not having that linear representation, they are called classified as non-linear. Generally, we are going for as a PG level, as a researcher, we are having there. Hello. Hello. It's echo is coming. It's automatically retrieving back. Data is retrieving back. Hello, excuse me. It's coming back. It's coming back. No, it's ICRTCS. If you are muting, then only I can talk, na? Yeah, thank you. So this non-linear optical property is said to be the important one for the crystals or materials to analyze the enhanced properties, especially in the filter applications, EC background. This is the representation for the NLO, non-linear optical materials. Next slide, please. Swinger limit. So, swinger is the limit which is said to be the electromagnetic field is expected to be non-linear. So, the limit represents the non-linear optical property like that, or non-linearity of the system like that. So, from which we can analyze that we are having the NLO materials like that. Generally, we are having two types of NLO applications we are using. We are having higher order, but generally second order and third order. Second order, Hudson-Perry technique, and third order we are using result scan. But some cases, some rarest cases, we are having on crystal. That also we are going to discuss about that. It's actually a third order crystal, but it shows second order property due to the strong hydrogen bonds like that. So we have studied for the third order as well as the second order. It has enhanced the second order compared to the potassium dihydrogen phosphate like that. So these are the representation, basic representation before entering into the field, before entering into the crystals like that. Next slide, please. Yeah, fluorescence versus luminescence. So whenever we are growing a nanomaterial directly or converting a macrocrystal to nanocrystal like that, we are having this UV, IR, Raman, and similar properties of either single XRD or powder XRD like that we are studying. So single XRD to analyze the parameters of the crystal, powder XRD to identify the indexing data, and UV for the electronic transition, IR for this change in the dipole moment and polarizability change by Raman effect, like that. When you are taking IR, there is no need to take Raman, but we are generally presenting for a comparative output or comparison like that. Main tool is if the material is having some flaw or if the material is new, we are identifying the fluorescence or luminescence. Generally, we are calling it as fluorescence or luminescence like that, but slight variation is said to be there. To identify the nanomaterials, nanocrystals, or bulk crystals, the variation is said to be found, and the enhanced variations in the macro and nano scale. From that, the energy gap is said to be deferred. From the energy gap, the application is said to be deferred, or it can be applied for different applications. The material can be utilized for different applications. So fluorescence is type of luminescence first. Second one, fluorescence is the result of absorption of photons. So it's a type of photoluminescence. In atomic fluorescence case, the elements can be identified. So what the material we have grown that can be identified. Fluorescence is taking place in atoms or molecules. And luminescence can be taken place in organisms, solutions, molecules, etc. So these are the differences. Next slide, please. Yeah. Crystalline solids, its growth or preparation method, as well as nanocrystallines. So here, crystalline method, the solution growth method is the best method for growing macrocrystal. It's a cheap and best method. When you are mixing two crystals in a particular, two materials of liquid or solid in a particular beaker, and you will get a good quality crystals by the solution growth method. And green synthesis method is a direct method to extract or to get the representation of the nanomaterials like zinc and other things. So these are the best method what we have utilized. We are having different method, Zagorowski method, Bridgman method like that, and gel method like that in crystal growth, and co-precipitation method, wet chemical method, hydrothermal method like that in the nanomaterial preparation. What we have mainly used is solution growth method for the crystal growth and green synthesis method for the nanomaterial preparation like that. Next slide, please. Yeah, this is solution growth method. So we are having comparative different liquids, and we are having the crystals. That brown representation is the crystalline solid. This is the general representation. The next one is it is a beaker containing liquid. Top of that, we are having some cardboard or wrapper. It's said to be tightly fixed with the holes, small holes, tiny holes over there to get evaporated. So after some time, after a few weeks, generally within 15 days, we are getting the crystals. And some crystals, it will go for more than months. And after that particular time, we'll get that extract of the crystal. Water or solution is said to be getting evaporated. So finally, we are having the crystal with some dust and all. We have to clean with the butter paper or neatly clean, and then a piece of that same is said to be analyzed for the purpose of single XRD to get that lattice parameters identification. From that lattice parameters, if it is said to be already solved crystal, we can identify and we can utilize for some other purpose. If it is a new crystal, then your parameters or data will be new like that. So these are the representation for the growth method by solution growth technique. Next slide, please. This is a method. Exactly, it is said to be the same diagram is said to be published in the Springer journal. So this is an exact representation of ZNO nanoparticles by green synthesis method. So we are utilizing zinc acetate with the urea as 1:3 ratio. We are adding ethylene glycol with the Azardica indica, that is neem leaf we are using. Then we have stirred with the magnetic stirrer. The same material, same apparatus used for the purpose of getting growth of crystals. Next, domestic microwave oven we have used. It's a simple method. Otherwise, they are going for some costly oven. Instead, we are using that household, that is domestic oven. Semi-colloidal precipitate we have obtained. And when they are wasing and finally distilled with that acetone, finally we are getting that ZNO nanoparticles, which said to be synthesized. This is a method of green synthesis method of ZNO nanoparticles growth. These are the growth methods. Next slide, please. Yeah. Now, directly I am entering into the material its level of output, applications like that. The growth method already we have discussed. Growth method is same, materials are different. If the crystal is said to be different, then we are having different output. Getting the different output, we are getting as the output of the particular solution growth or by the nanomaterial growth like that. So methodology is same, like Z0 nanoparticles like that. And also for solution growth method, the same type. The extract of the same macrocrystals or nanocrystal conversion or nanomaterial preparation, nanoparticle preparation like that, said to be different with the different elements. So bio-friendly and competent domestic microwave assisted method for Z0 nanoparticles from neem leaf. Here we are using the SEM as the analyzing representation. So SEM is the method of scanning electron microscope to identify the morphology of the crystals and nanoparticles. So surface morphology. So when you are having the bulk crystal, the outside, we do not have any identification of it's having either flaw or any damage. We cannot identify through our naked eye. So we need surface morphological effect using SEM, where we are having 1500 magnification, 3500, 7000 and more than 10,000 times with the range of 1 micrometer, 10 micrometer, 5 micrometer like that using SEA at IIT. So for the 20 kilovolt supply is set to be there, where we are identifying any flaw is set to be there in the material, then it could be identified with this change in the picture representation. If there is no flaw, then we can confine that the material is set to be pure, especially in crystals. When you are going for some light emitting applications in the crystal and other application in optical region, then we have to identify the flaws using SEM and all. If there is no flaw, then it could be go for good optical output based on that. Next slide, please. Yeah, you have to identify the material what we have grown using powder XRE. Since it is a nanoparticle, directly we are getting from the green synthesis method from neem plant. So the indexed representation of the particular nanoparticle what we have grown is said to be 100% perfect with the previously reported one. So we are identifying that Z0 nanoparticle is said to be grown perfectly and it's matched with that previously grown particle to identify the same. So what we have confirmed is we have grown a perfect nanoparticle like that. We can confirm it. We can recheck it like that. We can through this particular powder XRD. Next slide, please. Yeah, this is a method. SEM with EDAX. SEM is already represented. So it is EDAX. So weight percent as well as atomic percent for the zinc oxide Z and O. So O and Z is said to be present over there that we can identify through this EDAX representation of Z and O. Next slide, please. Yeah, this is one of the representation of photoconductivity of the Z and O, which we have grown using neem plant by green synthesis method. Here, for the first one is the red line represents IP. The black line represents ID, the dark current. So dark current is said to be lead over by IP. So this is a positive representation of photoconductivity. We can call it as positive photoconductivity like that. So we are having different applications of positive photoconductivity and negative photoconductivity, especially in the Z0 nanoparticles exhibit positive photoconductivity. That is the representation of this positive photoconductivity by this particular representation of nanoampere current with the field in volt per centimeter. Electric field is volt per meter or Newton per coulomb. When you are giving direct pressure, it's Newton per coulomb. When you are having this applied field or voltage, then it's volt per meter or volt per centimeter like that. Next slide, please. Yeah, that is the previous one related to the Z0 nanoparticles directly from green synthesis method. Now we are having bisglycine hydrobromide nanocrystals. So first we have to know what is said to be a macrocrystal. So bisglycine hydrobromide is said to be a monoclinic system crystal, and it's said to be having beta as 111.81. So it is measured on alpha and gamma is said to be same for monoclinic system when we are analyzing the 7 types of crystal system. And beta is said to be different and is said to be perfectly matched with the previously reported crystal system, from which we are identifying the sample is of initial powder of 290 nanometer Further, after milling more than 1 day, we are getting around 45 nanometers. From the 45 nanometer, we are directly using this because we are having glycine compared to the bromine. Bromide, that's glycine is having some effect of anti-diabetic using alpha amylase. So that we have checked with that particular macro and nanoscale, and we are reporting only the nanoscale here. Here that IC50 value is 29.8, from which we are confirming that this particular bisglycine hydrobromide BGHB crystal of nanoscale of 45 nanometer can be adapted for anti-diabetic property, and based on that glycine, it can be go for anti-inflammatory property also. That's yet to be reported. It's yet to be process is going on like that. So we are confirming this anti-diabetic nature using glycine, and we are reporting the IC50 value as 29.8. It's the main value for the concentration from which we are analyzing the final output of 29.8. Next slide, please. That is the concentration versus inhibition diagram. When the concentration is increases, inhibition representations also set to be varied accordingly. Direct method, concentration increases, inhibition rate also getting increased like that. So generally, macro scale IC50 value is high compared to nanoscale by value, but when the IC50 value is low, it's best preferred for anti-diabetic as well as anti-inflammatory property. So these are the two main points. So IC50 value for macro scale is more than nanoscale by value, but IC50 value less value is preferred for anti-diabetic property or as well as this particular type of drug analysis like that. So nanoscale is generally preferred over there. Next slide, please. Yeah, this is a concentration versus inhibition scale by bar chart. How much variation is there to identify or to analyze? This is a scale. Next slide, please. Yeah. Now, previously we have zinc oxide by green synthesis method. Here, ZNO with the CE dope. It's a laboratory preparation method, anti-diabetic work. The preparation method is said to be similar to the previous methods what we have discussed. So I'm not going in details about the preparation method and all. We are going for the analysis of anti-diabetic methodology for the ZNO CE. Here, 3 atomic percent, 5 atomic percent, and 7 atomic percent variations are there for CE doping of ZNO, where we are having this IC50 value as 28.97. Next slide, please. So it's 28.45 for 5 atomic percent. Next slide. So 28.01 for 7 atomic percent. So from which we can analyze or identify when the atomic percentage is 3 to 5, 5 to 7, it is said to be increased, your IC50 value is decreased. So we are going in a proper manner. Our material is said to be perfect. We can identify through this AD activity, anti-diabetic. So here I would like to say a few words about the materials. So we are having the material, we are analyzing for anti-diabetic property. So what is the refinement over there? So we have to analyze by what material the anti-diabetic property is said to be enhanced. Here using ZNO only, not with the cerium. So this material is based on ZNO, we are having the property, but based on your dopant, that mixing element, our AD values are said to be, IC50 values of this AD is said to be differed or varied accordingly. So this is the representation. And one more thing, the material can be identified. Suppose crystal we are taking, we are having good structure for the crystal, but nanomaterial, there is no proper defined structure, but we are confirming the nanometer scale and the powder XRD, we can index the material, nanoparticle. So variation can be identified. If the structure is very linear, it can be applied for some cosmetic, beauty care, and other general applications. If the structure is having some coumarin group or ortho, meta, para, special elements present over there, from that we can identify the material can be used for anti-diabetic, anti-inflammatory, anti-cancer. Based on this, based on the particular element present and the branching of which type of branching it has been taken place, either the ortho, meta, para position or special case from which you can identify. Because if the material is having benzopyran, then it can be used for anti-cancer property, anti-cancer applications. If the material is having coumarin group, it can be used for anti-diabetic, anti-inflammatory, anti-cancer, and some other tumor applications. So based on the material, we are having the classifications that we have to choose with the help of chemistry people, like the bonding, the application of bonding like that. So the one point is, if it is linear, we can go for some beauty, cosmetic, and other commercial applications. When you are having branched application, we are having some special applications in bio or pharma utilities. Next slide, please. So this is the identification of this particular material. Undoped Z1O, C doped 3 atomic, 5 atomic, and 7 atomic percent. The star is represented as C, the first one star. Next slide, please. This 3 atomic, 5 atomic, and 7 atomic percentage of C doped with Z1O is classified with this. There is no flaw is identified. The variations are with the good resultant output of Z1O doping, and no major flaws or no major representation of variations said to be obtained. So they are, most of them are said to be similar in structural representation also based on the doping. So from which the surface morphological effect of the Z1O with C is said to be with SEM. Next slide, please. Yeah, that's about related to the Z1O with CE, it's said to be over. Now we are having L-alanine malate, macro nanocrystals, antimicrobial, and fluorescence effects. Previously, they have not discussed fully on fluorescence and microbial. That we have taken because it is already a reported crystal. So we have gone for antimicrobial property and we are utilized for the MSc level project like that. So the XRD data gives this orthorhombic nature of the system. Alpha, beta, gamma is said to be same. If orthorhombic is there, alpha, beta, gamma same. So no need to mention over there. ABC is said to be different. And initial powder, we are having some macro scale and nanometer variation is up to 70 nanometers. So this, based on the time limit, the nanoscaling can be obtained using ball milling method. The fluorescent emission also is getting deferred. For macro, it is 399. For nano, it is 430, like that. So the variation is to be obtained. Next slide, please. So here, the fluorescence intensity versus wavelength. Here, red line is for macro, green for 50 nanometer scale, next 29 nanometer scale, and brown is for some 70 nanometer scale. Most of them they are asking, if it is less than 20 nanometer, shall be classified as quantum dot like that. So it's a particle, directly we are having some 70 nanometer. Quantum dot, they should be only applicable semiconducting representation like that. So we do not have that representation. We are having the particle size as 70 nanometer like that. We are calling it as particle size analyzer. Some of them they are calling as DLS like that. So these are the representation. They are asking, some of them they are having some doubt how the graph is to be starting from 0. It's not starting from 0. It's starting from 280 or 290 nanometer like that. So we are not representing the initial scale as 200. Starting from this, it's based on the emission value for the excitation what we have given. So it is emission based on the excitation. It varies according to the based on the nanometer scale what we have prepared for particular material. So this initial value is not 0. It's varied because it is a question asked in the journal representation. How it could be start from 0? Then we are in a position to clarify the doubt that it's not started from 0. The initial values, when it's said to be 100 variations, initially it's said to be around 200. So what we are confining this start is from around 280 nanometer, from which the input is around 200 plus. So enhancing is said to be obtained. So we are calculating the refranging property using the PL like that we are confining. Refranging is change in wavelength. That is called refranging property. Next slide, please. Yeah, this is LAM initial powder that we already discussed. The zone of inhibition that either it's said to be resistive or it's said to be sustained. So it is said to be having the positive effect based on this particular nanoscale for Staphylococcus species antimicrobial property. Next slide, please. Pseudomonas species that also we are having. Zone of inhibition varies. For E. coli also we are getting. So one more clarification they need. How we are confining, either it's said to be malate group or from that alanine group we are getting this result. So malinate or maleate, these are the two groups, they are having less effect. L-alanine having more impinges or more impact over antidiabetic and antimicrobial property. It's one of the best amino acids. So this is the main classification. Next slide, please. Yeah, this is the main one, main paper published in the elsewhere. What we have done is generally they are having macro scale for the theoretical calculation using software and experimental calculation in laboratory purpose. They are converting the macro, breaking into small pieces in nano, comparative output like that. Here, the CUS, ACT and CUS NAT nanostructures of monowire using computational approach, using software only directly we are using. There we are comparing this ionization potential and EA, electron affinity maps. So the paper is only 2 pages. So most of them, they are having the opinion, when we are having 22 pages only, we are writing the paper, then only it can be published like that. It's only 2 papers. The content is, we are having the software, we are utilizing the same by repeated structure. The state of density is said to be default, from which we are giving the conclusion. So it is 2.5 pages, including references. So it's said to be accepted and published in research. Elsewhere article as a research article, elsewhere journal as a research article in materials today proceedings like that. So what is the conclusion is, what we have given, based on that, the output will be. It may be a 2-page or 20-page like that. So your work should be proper. This is the best example, because some of them they are asking, they are said to be giving mail. So what is the representation for putting this? So if you are writing 20 pages or 2 pages, what is the conclusion of your material that impacts this, your result, and enhance the data for your purity or efficiency? Then only we can go for best journal based on our data and write-up. Next slide, please. Yeah, here absorption energy is said to be identified. So it is 5.2303 for ACT and NIT. So this classification is there. NIT we have not yet published. ACT we have published like that. This is the small information related to that. Next slide, please. Yeah, this is the structure for CUS ACT nanowire. So monowire is a single layer representation, monowire. So nanowire representation is by CUS. We know copper and sulfide. From that, we are having this diagram. By theoretically, by software, we are getting the same. Next slide, please. This is the nanowire device fabrication. So we are having this gold atom, both sides. See, AU. So it's said to be matched with the CUS. CUS is there, from which we are having this pattern. We are identifying this nanowire device for a better application by variation of this density. Next slide, please. Yeah, we are getting this HOMO-LUMO band gap using this software. It's 1.23 as the occupied system and lowest unoccupied system like that. So it is a system. Next slide, please. Yeah, this density of states. penny model and other models, we are here and multi-layer representation. So we are confining the density of states. Here, energy value is to be presented for the occupied orbitals as green and virtual orbitals as red, and density of states spectrum as represented by the blue line. So this is the representation for the particular CUS ACT system, mono wire system. Next slide, please. Yeah, now we are entering into our main work. It's the best work we can confine. It's said to be a third order material, but exhibits some second order property due to strong hydrogen bond that already I represented. So it's a dielectric, fluorescence, filter, nanotubology, and photoconductivity of macro and nanocrystals. So single
Hello, sir.
Yeah, there is a small disturbance in the connectivity. Now we are proceeding the same. So fluorescence change in the energy states when you are having that input in wavelength, the output is said to be enhanced. With the enhanced representation of change in wavelength, we are identifying the same. Next, filter applications. We are calling it as filter influx. No, previous slide only. Previous slide only. Yeah, filter applications. We are calling it as influx. And tribological, we are confining only nanotribology. Macro, we have not discussed over there in the particular journal paper. So tribology, wear and tear of the material. So if our material is said to be very strong, we can confine our material as the tribological enhanced property of the material like that. If suppose our material is said to be not that much strong, when you are having different materials like wood, iron pieces, steel, or any other material like aluminum, copper, like that. So we are having this our material as the coating. Based on the coating, we are having some tribological enhanced property we are identifying. Next, we are having photoconductivity that I have already we have discussed that this zero nanoparticle is positive. Here in this case, it's said to be negative photoconductivity for the particular specimen. The solution growth method of this particular crystal is said to be given. So final crystals are obtained after a few weeks when we are having this mixed solution properly evaporated with the beakers. Next slide, please. Yeah, this is the representation of equation of the crystal growth method of this particular CPD crystals, the red line represented elimination of the material. So it's by eliminating this red lined one, the atoms, we are getting this particular structure. The black lined one after the arrow symbol as the product we are getting, that is the crystal structure, molecular structure representation of the crystal what we have grown. So this is the best one, and we are having the good output in the particular influx filter applications as well as in nanotribological. Based on that, the paper is going to be thrown. Next slide, please. Yeah, this is a parameters. It's a monoclinic system. Alpha, gamma same, beta is said to be deferred. So it's having some empirical formula, and influx for the nanoscaling is 3.1145, from which we are identifying the filter properties. Filter applications of the material can be identified with this. Next slide, please. Slide number 37. Yeah, now we are entering into the dielectric property. So macrocrystal and nanocrystals are represented with frequency as well as dielectric constant. So when we are going for frequency change in value, increased value, your dielectric constant is said to be decreased. Is the representation from the dielectric constant. And dielectric loss, when we are increasing the frequency, log frequency, the dielectric loss is said to be reduced or minimized like that. These are the representation of the nanocrystal as the top one and the bottom one as the macrocrystal for the dielectric constant and dielectric loss. Next slide, please. Here, dielectric constant with the temperature also we are identifying the variation in the temperature and the decrease in the dielectric constant nature of the particular CPD crystal is said to be given over there. So the all type of polarization. So when you are representing the class as Moshati, this polarization are different 4 types of polarization. So all the including from ionic to this space charge like that, all polarization are said to be confined with this particular dielectric constant. Then only we are having the good impact in dielectric output. That is said to be discussed here. Next slide, please. This is dielectric loss with the temperature. Again, when the temperature is said to be increased, the variation is said to be obtained for different frequencies, and except that 100 hertz, the remaining more or less the same output is said to be obtained. Next slide, please. Yeah, here, say the black line is said to be on the top. So it's a representation for the negative value of photoconductivity for the dark current and photocurrent. So this we are identifying. So it's a negative type of photoconductivity for the particular specimen of CPD in the photoconductivity applications. We are confining it. Next slide, please. Yeah, here. So I have given one small variations. We are having the macro and nanoscale. So this intensity is just wavelength for 407 nanometer and 370 nanometer is said to be given for the macro and nanoscaling for the CPD crystal. So based on our macro scale and converted into nano form by milling or any other method, the variation in the nanometer is around 20 plus nanometers. Sometimes 6 nanometers only is said to be obtained. So from which we are identifying that variation is said to be due to this particular impact of macro size and nano size, the scaling effect. Next slide, please. So this is a topological representation. Our material is to be used as a helical spring. This is called helical spring. The diameter, the radius, space value, total distance like that we are identifying. We are having the formula. When you are applying the formula, the stress can be calculated. It's not like a normal stress what we are applying in the force per unit area what we are getting in the lab. It's a variation in the stress. Based on that, so many parameters are said to be discussed, and related to that they are said to be also disturbed based on the stress value that is said to be calculated. That's what the tribology is called, wear and tear of the specimen. So nature of the specimen, right? Friction parameters. It's general tribology. We are not using any friction here. So wear and tear of the specimen, change in the coating, outer surface area, surface common effect, length, density, property of the variations can be obtained. Next slide, please. Yeah, the nano influx is said to be 3.1145 for the 16 nanometer size of the CPD crystals. The tribology study was successfully carried out for mechanoelasticity and other applications. It's having greater impact based on the influx in the electronic sectors and the tribology effect for mechanoelastic industry for life of coils based on that stress and for better stiffness of the samples that could be identified. Next slide, please. That is the same crystal using anti-diabetic property, used for anti-diabetic property, CPD crystal, the same XRD data. Next slide, please. Next slide, please. Here, macro and nanoscale crystal, the variation is obtained. Small variation is said to be obtained in concentration versus inhibition. The concentration increases, inhibition first increases, and then it's said to be having some sustained or moderate values. Next slide, please. Alpha amylase inhibition concentration. Inhibition versus concentration of the CPD crystal. We are having 27 for nano and 29 point macro. So nanoscale is preferred for the particular CPD crystal for anti-diabetic property compared to the macro scale. Based on the effect. Yeah, anti-inflammatory property. Here, this component is having benzopyran. So mainly by benzopyran, and we are having any alanine component. Based on that, we are having this enhanced output of anti-cancer as well as anti-inflammatory properties. So again, we have nano is said to be lower value, so it's said to be preferred compared to the macro scaling and anti-inflammatory scaling. Next slide, please. The same graph for the concentration versus inhibition for macro and nanoscale. Nanoscale is preferred because the concentration is said to be more, but IC50 values less. Like that. Next slide, please. Yeah, the same effect is said to be applied for anti-diabetic in case of BGSP, bisglycine hydrobromide. Glycine is there. Based on the glycine, there is an enhanced output of IC50. There we are having 290 nanometer as the initial scaling. So 290 nanometer, so probably it is 0.2 microns, right? So 0.2 micron, very, very less value. So we can confine this as nanometer scaling of the macro scale, the effect of nanoscaling output of anti-diabetic property of BGHP that can be confined. Next slide, please. So that is a graph for that particular anti-diabetic and anti-inflammatory categories where concentration versus inhibition is discussed. There generally they are having the usual practice of slightly increasing. Here, huge amount of increases from the 10 to 80 is said to be obtained. Next slide, please. Tribology or nanotribology. Next slide, please. So this is a graph, or this is the structure of the figure. Already I have discussed for CPD crystal. Same effect we have tried for other crystals. Next slide, please. Yeah, TFM PHB. It's said to be not yet published. This particular crystal. So for which the tribological effect, the macro tribology for the 0.91 gigapascals, stiffness is 11.379 kilonewton per meter. The nano tribology is also obtained. Next slide, please. There, it's 0.221 on GPa. Spring deflection value of 0.09 millimeter is said to be obtained. So we are having the comparative coating effect of the same TFM PHB materials for getting the stress analysis by tribology. So thin films also corresponds to 3.6127 microns. That's also we have just tried how the coating will be when finally identified for the glass coatings as a thin film. because we are having macro scale and nano scale. The thin film is only missing. The macro and nano scale is said to be published. So how it is said to be varied in case of thin film like that? The thin film value is in between the macro and nano scale, the value of either the influx or any other parameters like that. Because it's like a coating, it's between the nanoscale, nanometer, and micro scale, macro scale or micro scale, micrometer. So it is in between. We can call it as of the order of 10 to the power minus 8 like that. That we can identify. Next slide, please. So it's used for based on that influx value for electronic gadgets, mechanical elastic production for coils, life of coils or verve of coils like that. Verve means directly stretching from which we are getting that. Life of coil means they're using so the stretching or the effect of impact of the stress based on the life of this particular spring or the machine can be identified. That's why we are identifying the material tribological nature for the enhanced productivity. Next slide, please. Yeah, here, picolinium malleate data is to be given the IC50 value for nanoscale. Macro scale already we have discussed. The nanoscale is 20.2. So here, based on the picolinic acid and malinic acid, the picolinium malleate is said to be given here this crystal PM. Picolinic acid has the enhanced effect of anti-diabetic and anti-inflammatory activity. And nanoscale, it's said to be 20.2. And macro scale, it is an increased value of 20.26. And some cases, based on the nanometer variations, 20.3. So macro is said to be 20.3, nano is 20.2. So 0.1 variation is obtained. So it is a very meager variation. It's based on the purity of the sample. If the sample is said to be more value of nanometer scale and it's a more disturbed spacing and all, then it will have effect of output will be more. Since it's having less value, the purity of the sample is said to be not disturbed. Only the variation of the scaling is said to be given. So that's why 20.3 for the macro scale, 20.2 for nanoscale, 0.1 is said to be obtained. Next slide, please. Yeah, the same. We are having this ABC alpha beta gamma. That's the usual practice. So glycine lithium bromide. Glycine will have the more impact on the bio applications compared to the lithium and bromide, because lithium is said to be used in battery and electronic applications, not more on these pharmaceutical applications. Next slide, please. Yeah, this is a scaling of the data of single XRD for the scaling as well as nano scaling up to 40 hours of 34 nanometer. Next slide, please. This is a filter application. So influx of nano scaling will have more enhanced filter applications compared to the macro scale. Next slide, please. Yeah, 403 and 397 nanometers for nanoscale and macro scale is said to be given. So correspondingly, the band gap is also said to be varied in electron volt, from which we are identifying the material can be used for the particular non-centrosymmetric applications, especially in optical cases. Next slide, please. Yeah, anti-diabetic case. So diabetic is an ailment that transpires the human blood glucose. So I'm giving the definition here. We have explained all the data previously. It's successfully elevated. How much it can control when the insulin secretion is said to be disturbed, how much your material can be used as a substitute material or substituent for maintaining diabetic nature body or the blood. So generally we are having the type 2 enhanced diabetic only. Type 1 diabetic we are not using, and we are not having this effective nature of the same, because based on the material we can confine that our material can be used for the application of the anti-diabetic nature like that. We are not confined and we are not making into a drug directly. That we have to go for patenting approval from the medical. It's said to be a decision. We are giving anti-diabetic property enhanced in vitro property. Like tablet and all. So identification of the please. My difference is that we have already put glucose content at how many is said to be changed. Based on that, we are going for some drug analysis like that. Next slide, please. Yeah, glycine or not bromide. Bromide, if it's said to be utilized, it's very meager amount. That is a previous enhanced research it's said to be carried out. Next slide, please. Yeah, bliss glycine lithium bromide monohydrate. It's said to be not yet published. We are going to publish soon. That work is set by powder XRD and the crystal system, whatever we grown is said to be given. Next slide, please. The sample with time versus size in the nanometer scale is said to be obtained. A small variation in the graph. Next slide, please. Yeah, fluorescence effect for the macrocrystal is 403 nanometer. Next slide. For nanoscale, it's 397 nanometer. So around 6 nanometers only obtained for this. So we can identify the purity of the sample based on this fluorescence effect. And there is a change in the energy band also. That energy gap or band gap also. From there, we can identify the utility. Next slide, please. Yeah, this is the overall conclusion. So what is our conclusion is we are having the enhanced output. The enhanced output of the crystal by good quality NLO, nanocrystal, and nanoparticles. Based on that, we are identifying how perfectly it is to be grown, either by single crystalline or this powder XRD representation for the macrocrystals as well as nanomaterials. And the nanos directly obtained milling. Nanoparticles directly it is to be synthesized. Nanoscale is by green synthesis method, or it can be converted the macro scale to nanoscale by milling method. The material is used for the purpose of anti-diabetic or anti-inflammatory only. That what we have shown now. And the anti-cancer property also there. That's yet to be discussed. And some of the data to be obtained. And it some of the stuff as basically related to physics, but I'm in charge of the R&D. So just a list of publication in the bio or pharma or medicinal applications up to 2019 to 20. Next slide, please. Yeah, we have 200 plus UGC publications, including our MSc projects, 100 plus UGC care journals, since it is a revision from that UGC board, especially from the government of India, and 50 plus Scopus SCA, SCAE journal publications, especially in the Corona period. We have some 34 publications, 27 in the elsewhere, and 6 paper in the Springer. So 33 papers in the Springer, 1 paper in the general Scopus. So around 34 papers in the Corona period from last January to till December. And throughout my service, I have presented 325 plus conference publications. Next slide, please. This is the research gate score. This is a predominant thing when you are doing research. Next slide, please. Yeah, this is a elsewhere publication of the CPD crystal. I already told the anti-inflammatory and anti-diabetic property. Next slide, please. And this is the AAP, American Institute of Physics journal publications. This for LPNP TGH. That already I have discussed the same in a different conference. So I will not discuss that data. So it is called some Alzheimer's syndrome. Alzheimer's syndrome is we are not recollecting the things. The memory is said to be lost in the brain due to the nerve deficiency, and we are not recollecting the things for the past 1 week like that. Previous things we can recollect, present things we can recollect. So that is said to be that affected people, especially the aged people, there they can be given the particular material like LP and PD gauge from which we are identifying that can be cured like that. So this is the molecular harboring process to identify the effective nature of this Alzheimer's syndrome using the LP and PD gauge. Next slide, please. This is another one, theoretical calculations of this particular crystal. And thanks for one of my best collaborators because he has done the theoretical work. Calculations he has given, and I have written the paper. Next slide, please. This is another paper. LEAF crystal hardness previously it is said to be not studied, so that we have studied and we have published in the AAP conference proceedings. It's one of the MSc students project. Next slide, please. This is also ACDC conductivity studies of L-alanine fumarate. One of the papers related to the government college scholar who has done the majority work in electric. Next slide, please. Yeah, this is some anti-diabetic property. So L-alanine will enhance the property of anti-diabetic, published in the AAP proceedings. Next slide, please. Yeah, anti-diabetic property of L-alanine malate. It's published this acceptance letter from elsewhere. Next slide, please. Next slide. Yeah, this is also LVP from material root proceedings of the elsewhere. Next slide. Yeah, this is the main one. So perspective approach of zero nanoparticles for previous slide. 81, slide number 81. Yeah. Solar cell applications of the zero nanoparticles, that is said to be from 81, slide number 81. So that is a zero nature. It's a Springer applications. Solar cell we have not yet discussed, that we will discuss soon. Next slide, please.
0.
Next slide. Slide number 82. Yeah, this is one of the journal of UGC, and this is said to be the dielectric property I already told. We have, with the help of the government college scholar Mr. Kulanji, we have done this CPD crystal published in the Springer of 2.2 impact. Next slide, please. Yeah, this is one of the most important crystal, 2,5 dPPA. So many things we have written in proper manner, and finally we are getting this dPPA crystal in the published in the elsewhere optic journal. Recently we got the same. Next slide. There is also 3,3 D32 DMBC crystal for thermal and mechanical applications and dielectric and computational. I would like to thank the scholar Mr. Kumar for his work, and we have published the same in the Springer Journal of Material Science. Next slide. This is one of the journal in the UGC care list. There we have used the tinea therapeutical characterization, that we got some collaboration and we got the permission to utilize our material for some of the bio and pharma utility. Next slide, please. This is the dielectric and magnetic properties of the ZNO nanoparticles obtained from Allium cepa and Raphanus sativus. Allium cepa is nothing but onion. So that's said to be evolution, AM's ME, and we got the same published in the Springer. Recently, the last work we got done in the Springer journal for 2020. Next slide, please. Yeah, wish you all the best for everyone. And next slide, please. Thank you, one and all. Next slide, please. If you have any queries, you can ask. Any queries? Yeah, you can ask for any clarifications or queries.
Dear participants, is there any question?
Yes, someone need my mail ID in the chat. I will give. I have 2 mail ID that I will give. This is my first mail ID. Based on my MSc degree I got done. And presently, this is my second mail ID. I have given the 2 mail IDs. You can refer it. Someone asked it. Sir, where did you carry out the tribology study? Very good. So if you are having the enhanced setup, so any coating from which your material, any iron materials, your material is set to be coated, we can do the stress analysis by yourself. If you are having the enhanced facility in your mechanical system or mechanical engineering department from which you can get. Otherwise, in Andhra they are doing. So from which we can get. And North people, they are having the surfactant effect. So this will lead to the surfactant effect, change in the orientation and all, the material property. So from which you can get that tribological work. And probably you will get that copy of that video. Someone is asking that copy of the video that you can contact the convener. Ma'am will provide. So this is a tribological study and influx also. So we have so many types of filters, the optoelectronic filters, and especially the ECE people they will have that filters they are using for the different applications, signal to noise ratio, variation in the enhanced properties, band can be applied, different bands can be stopped, different bands can be utilized like that. But what we are using is we are having the material. We can use the material for macro scaling, use the material for nano scaling. Variation can be obtained, that can be given. Or previously you are having the zero no material already studied. You can use your material from which you can identify how much variation is there. Influx is nothing but how much you can insert. That is the general representation like that. Right? Yeah, you can refer the mail. You can get the video, contact the convener of this program, and you have any doubt, you can ask. Yeah, feedback link they will provide, I think. Yeah, they have given that forms something. You can refer it. Thank you, one and all. I have given the mail ID. You can ask if you have any doubts and like that. Thank you.
Sir, thank you, sir. Thank you so much.
Yeah, ma'am.
Thank you for elaborating the nanomaterial concepts in a very clear and easily understandable way. Thank you so much, sir.
Okay.
The roots of all goodness lie in the soil of gratitude, which is the most exquisite form of courtesy. Now I request Mrs. Shobana, Assistant Professor, Department of Physics, for the gratitude note, vote of thanks.
Thank you, ma'am. Gratitude is one of the least articulate emotions, especially when it is deep. Good afternoon, everyone. So we have reached the end of this beautiful function. I'm Shobana. I am here to present the vote of thanks for today's webinar. First of all, I would like to thank Almighty God for making today's webinar a great success. On behalf of Mohammed Salek AG College of Engineering, the principal, management, and the staff members, I would like to thank our webinar speaker, Dr. K. Sendilkannan, for enlightening us with their knowledge. Today's webinar was full of knowledge and interesting things. It gave deep insight into the topic and also revealed some interesting facts. The points where he told us about the nanomaterials and its applications was really informative. I am pretty sure the precious knowledge that Dr. K. Sendilkannan gave us will definitely help us in our studies and future. Once again, I would like to thank Dr. K. Sendilkannan for taking out time from the busy schedule and enlightening us with the knowledge. Thanking you so much, sir. I would also like to thank our principal, Dr. K. S. Srinivasan, for giving permission to organizing this webinar session. I want to thank all the participants for active participation. A special thanks to the organizing committee for their support and coordination. With this warm word and a kind message, we move to the end of this today's webinar. Thank you.
காலையில அது